would also like to welcome you to this event and to my presentation about the migration from classical CANopen to CANopenFD. So after having heard a lot of CANXL, the topic is now a bit more the older protocols like CANopenCC and especially how to migrate to CANopenFD. My name is Gedenk and I'm working with CAN for 23 years now. I also have a degree in electrical engineering, and yes, I'm dealing with CAN and CANopen for more than 20 years. At the beginning, I would like to say a few words about the company Emotas Embedded Communication, and after that, I'll try to introduce a bit classical CANopen and CANopenFD. Well, I wouldn't call it an introduction, but I want to highlight the features which are different and which might cause migration issues afterwards. And then after highlighting the migration issues, I'd like to present possible solutions for device manufacturers and for network installation. I am one of the co-founders of the company Emotas Embedded Communication. The company was founded with a different name in 2012, and we are active in CAN automation in various working groups since the foundation of this company. And even before, I had been active with CANopen. And in 2017, we released the first CANopenFD protocol stack after the release of the CANopenFD specification. And well, we offer a lot of different CAN software solutions. So beyond CANopen and CANopenFD, we provide also protocol stacks, bootloaders, and tools for other CAN and CANFD based protocols. But today, the topic will be classical CANopen and CANopenFD. I start with a brief introduction. Obviously, CANopen, classical CANopen and CANopenFD are industrial networks based on classical CAN and CANFD. So they use classical CAN and CANFD, and they provide standardized communication services in order to achieve a standardized way of communications between various devices. So the protocols provide, for example, ways to read and write parameters or to send signals and to receive them in a standardized way. And both classical CANopen and CANopenFD define a standardized device behavior in so-called device or application profiles. So, for example, there is a device profile for generic I/O modules, and this device profile defines how a generic I/O module shall communicate in a CANopen or CANopenFD network. And there are also application profiles in CANopen which define the behavior and the communication of a complete application. So, for example, there are application profiles for light electric vehicles or for elevator applications, and these device profiles define a standardized behavior and the communication for them. Well, classical CANopen had been released in the first specification for classical CANopen had been released in 1994, and the first version of the CANopenFD specification has been published in 2017. From our business, we sell or we license protocol stacks and tools, and we still see increasing sales in classical CANopen and, of course, in CANopenFD. And in CANopenFD, the sales figures are increasing, of course, but they should or could increase a bit more. But there might be some migration issues, and following slides, I would like to explain ways how to overcome these migration issues later on. Now the short introduction into classical CANopen and CANopenFD. These boxes here shall be a CANopen or classical CANopen or CANopenFD devices. And the basic idea is that on the CANopen application layer, the devices exchange so-called CANopen objects. A CANopen object can be a single byte or multiple bytes, a parameter or a signal which has 4 bytes, or a longer string, maybe 20 bytes, or even a firmware which has, for example, 0.5 megabyte or 2 megabytes. And this is from the application point of view, just a single CANopen object which is exchanged from or sent from one application to another one. Well, of course, these CANopen objects might be longer than the 8 bytes or 64 bytes of the classical CAN or CANFD frames. So CANopen and CANopenFD define rules how to transmit these CANopen objects on classical CAN and CANFD frames. And well, there are a lot of different services in CANopen, services to read and write parameters, or services just to send a set of signals in one CAN or CANFD frame. I can't explain all of the protocol, but on the following slides, I would like to highlight which CANopenFD services have been changed compared to classical CANopen. Well, CANopenFD is the successor of classical CANopen, and of course, it's based on CANFD, and it uses CANFD, and it uses the higher bit rates and the longer messages. So the idea is to use the features which are available from CANFD. And when CANopenFD had been developed, there was an idea to, of course, to use the new features CANFD provides, and also to add some more flexibility. As I mentioned earlier, first version of classical CANopen had been released in 1994, and when CANopenFD was standardized before 2017, there was the idea to add more flexible features. So we have a more flexible USDO service, and we have obviously longer PDOs and emergency messages with an increased amount of information. And well, now with CANopenFD, we have also XML-based device description files, and these are the most features which have changed, and now I'd like to address them in detail. In classical CANopen, there is the so-called SDO protocol, which allows a one-to-one communication between different devices, and it's a service to read and write objects or parameters from multiple devices. USDO with CANopenFD, it's the new replacement or enhancement of that. And obviously it uses the longer CANFD frames. And additionally, it provides also the way to broadcast parameters. For example, to write a parameter in CANopen terms, an object in all devices at the same time. Or to read an object or the same parameter from all devices. And additionally, routing between multiple CANopenFD networks had been standardized directly with the USDO protocol. And using USDO, it is now possible to have a direct communication with between two devices without specific configuration efforts that had been necessary with classical CAN-open. But I don't want to go into more details here. Just one slide, how a so-called expedited transfer looks like in CAN-open-FD. And the basic idea here is a so-called USDO client initiates the transfer and sends a CAN-FD message to a server, and it basically can use the complete 64-byte of the CAN frame, and it indicates index and subindex is the address of the parameter, and there's a data type and size information, and up to 56 bytes of data with a so-called expedited transfer, which fit into one CAN-FD frame. And there are also segmented transfers for longer, but I don't want to discuss them here. And USDO transfer is, there's always a confirmation or a response sent back from the server confirming that the read or write access had been successful, or not. Well, the USDO service in CAN-open-FD is the service to read or write specific parameters, and in classical CAN-open or CAN-open-FD, one can use so-called PDOs to put multiple signals into a classical CAN or CAN-FD frame. And well, with classical CAN, we only had 8 bytes. And so the number of signals or CAN-open objects and CAN-open terms one could put or send in a single PDO was limited. So for example, there is a CAN-open device profile for drives, and this CAN-open device profile defines that the drive may have a control word, some mode information, and target position, for example, and target velocity, something like that. And if you want to send them in classical CAN-open-FD PDOs, you have to have multiple PDOs. But with CAN-open-FD, you can use all the 64 bytes of the CAN-FD frame, and you can put multiple signals or objects in CAN-open terms into one PDO and send them. It's especially better for synchronization on the receiver side if you have multiple objects which belong together in the same message. So, and well, this is a great feature of CAN-open-FD to have longer PDOs. But if you want to mix classical CAN-open and CAN-open-FD devices, there will be some challenges, as you can see on later slides. And the third and last improved CAN-open or CAN-open-FD protocol are the emergency messages. Emergency messages in CAN-open in general provide the functionality to send some error information from one device to all the others, basically. And with classical CAN-open, it was limited to 8 bytes, and with CAN-open-FD, we can use 20 bytes, and so there are more information inside an emergency message now with CAN-open-FD. That's the summary of that. These are the changes or the new features of CAN-open-FD. And now let's have a detailed look at migration issues and possible solutions. Well, the biggest problem here is that the data link layers are not compatible. You cannot mix classical CAN devices with CAN-FD devices. So you cannot mix classical CAN-open devices with CAN-FD devices in one network. That's well, the classical CAN devices will detect an error if they receive CanFD frames, so you cannot combine them. Of course, the new CanFD or CanOpenFD devices are able to handle classical CAN frames, but the older ones can't. So without any changes, you cannot mix existing classical CANopen devices with CANopenFD devices. Another migration issue is that if you use CanFD or CanOpenFD, the bit timing configuration, or especially the sample point, has to be very specific. So all CanOpenFD devices have the same clock frequency for the CanFD controller and the same sample point configuration, because the bit timing switch happens at the sample point of a specific bitrate switch bit. And so these bit timing configuration have to be have to be the same for all devices in the network. So if you have CanOpenFD devices from multiple vendors, you have to make sure that they all follow the CanOpenFD bit timing specifications. Well, on the application layer, if you want to mix them, they have to deal with longer PDOs and with broadcast. And well, if you want to start developing CanOpenFD devices, you will need to have device description files in the XML format, but that's not a big deal. There are tools for that. Well, if we look at the migration issues, one can say that the incompatible data link layer is the biggest issue, but there are some solutions for that, but there are some solutions. One solution is that you use a so-called CanFD shielding transceiver. So a transceiver that is able to shield CanFD frames from the network to the CAN controller. Well, it could be a solution, but you have to reassemble your hardware, replace the transceiver, so it might not be the best solution. But using such CanFD shielding transceivers, you can build devices which act or work as classical CanOpen devices, but can be used in a CanFD or CanOpenFD network. But there's another problem. The host controller has to support both protocols, both CanOpen, classical CanOpen and CanOpenFD, and also the SDO and USDO service for both protocols. So if you imagine that if you have such devices which can ignore CanFD frames and can receive and send classical frames, you still have to use the old classical CanOpen protocol to address them. So your host controller in your network has to be able to support both CanOpenFD and classical CanOpen. But if you could go that way, and there are CanFD shielding transceivers available from multiple manufacturers. But if you are a device manufacturer and if you start developing new devices, I would suggest to build devices that support both CanOpen and CanOpenFD. So, well, obviously it requires the usage of CanFD capable controllers and transceivers, but it's not a topic anymore. You can get CanFD, you can get microcontrollers with CanFD inside from nearly all microcontrollers, and it would be a good idea to use a protocol stack which supports both CanOpen and CanOpenFD. Well, our CanOpenFD supports that, and I imagine that there are other manufacturers as well that allow the selection of the protocol at startup. Or you use CanOpen to CanFD bridges, so that which have classical CAN-open side and a CAN-open-FD side. Might be also possible, but I think that it's only an idea for very low numbers of devices. Yeah, for network installations, basically it's similar. Could use, or the basic idea is to improve your signal quality in your network and to keep your topology for higher bit rates. It's recommended to use CAN-FD SIG transceivers or CAN-XL transceivers, which also provide the signal improvement capability also for CAN-FD signals. And you could do partial networking, and there are transceivers with selective wake-up functionality. You could wake up the CAN-open devices only if needed, but again, you will have to have a host controller in a network which is able to speak both CAN-open and CAN-open, or classical CAN-open and CAN-open-FD. And well, maybe the easiest solution is if you don't want to start with only CAN-open-FD devices, is to have gateways and bridges and to separate your networks into classical and CAN-open-FD segments. Well, I had mentioned earlier that we at Emotas are a software company, and we have a software solution for a CAN-open-FD proxy or gateway software. So a software that on one side acts as a CAN-open device, a CAN-open-FD device, and on the other side as a CAN-open classical CAN-open manager. So the software is able to emulate multiple connected CAN-open devices as CAN-open-FD devices in a CAN-open-FD network. Well, of course, it acts as USDO server on the CAN-open-FD side and as an STO client on the CAN-open classical CAN-open side. PDOs, NMTs, and heartbeat messages are forwarded in both directions, and we have this implementational software available for multiple targets. I would like to look a bit deeper into this CAN-open-FD gateway software. So basically, there are two options. Maybe this gray box here shall be the gateway, and this is the CAN-open-FD network. We have one manager here, and this software emulates 3 CAN-open-FD devices and has, in this example, 3 CAN ports, and it acts as a manager for classical CAN-open devices. But well, it would be a bit more efficient if you had, for example, 1 manager and 1 classical CAN-open network, and still these 3 classical CAN-open devices are simulated or emulated as CAN-open-FD devices. So a CAN-open-FD manager is able to communicate with them. Let's have a look a bit how the communication works, or how the CAN-open and classical CAN-open-FD and classical CAN-open services are translated, so to say. This is a screenshot of one of our tools. It's a CAN analyzer which supports multiple CAN interfaces and multiple protocols, and basically, and here the green CAN messages basically are the CAN-open-FD messages on the interface 2, and the black one in the background are the classical CAN-open messages on the interface 1. And here in this example, you can see that there is a USDO transfer from a node ID 65 to a node 16. And here's the response of the USDO, and on the classical CAN-open side, the gateway has to send a so-called segmented SDO transfer, because we want to read a longer object, which in this example has 22 bytes, and we need multiple classical CAN frames to read that. So basically, on the CAN-OpenFD side, the manager sends a USDO to the gateway. In the gateway, there are multiple STO messages, and the gateway sends a USDO back. There's nothing special. That's just the example. And well, the other option is the PDO routing. Well, there's an easy way. If you, even in your CAN-OpenFD configuration, use only 8-byte PDOs, such a gateway could just forward the PDO, because if you have an 8-byte PDO on your CAN-OpenFD network, you can just send it as an 8-byte PDO in the classical CAN-Open network. Well, that's easy, but unfortunately, it does not make use of the advantages of CAN-OpenFD, and so it's also possible to send longer longer PDOs on the CAN-OpenFD side, and well, you have to split it into multiple PDOs on the classical CAN-Open side. So it definitely requires configuration, so it cannot be done that easily. So anyway, there are gateway solutions available, but maybe the best idea is to start with a new CAN-OpenFD development from scratch, or to build new CAN-OpenFD devices. And well, if you want to start with a CAN-OpenFD development, we offer a CAN-OpenFD starter kit. Well, it comes with a nice green box, but basically it contains a microcontroller and a CAN-FD interface, cables, and an evaluation version of our CAN-OpenFD stack. So it can just download the software and start with your CAN-OpenFD development. If you already have all the hardware components, this software is available for free for the download. And if you want to not only start with CAN-OpenFD, but if you want to do a complete CAN-OpenFD development and like more tools and products, we offer a complete tool chain around CAN-OpenFD for device development, network design, CAN-Open stacks, CAN-OpenFD stacks, obviously, and CAN-OpenFD bootloaders. Well, and now I would like to thank you for listening to my presentation, and if there are questions, I would like to answer them.
Maybe from my side, so Thorsten, you remember together we did a similar task when we opened up embedded CAN-Open networks with regard to a request from an Ethernet-based network. And there we had also a similar issue that there might be larger, powerful commands coming from a higher layer Ethernet down to a CAN-based embedded network. Now we have there the CAN-OpenFD network. So when you have the USDO, you may also have the issue that you have very powerful commands. You depicted it somehow, that there may be one command going to several subnetworks. Do you have considered this somehow in your approach, that such powerful commands may take time and you may need a kind of indication to the higher layer network?
The response will be sent later. Yes, probably. Yes.
Okay.
Yeah. But there are physical limitations. If you pushing the CAN-OpenFD network in terms of bus load to its limits, you cannot forward it to. We can't do magic. So
So we had also some issues like how was it called, resource management and so on. So this could be then also maybe of interest. There was now also a question, what's the programming environment of these stacks?
Ours, these stacks are written in NCC, so they are mostly targeted for microcontrollers. Yeah.
Okay.